Hello, we're going to work on multiply a decimal by a power of 10. And so I want to talk to you about an easy way to do this that's very simple, straightforward, but I also want to show you why it works. So to start, I'm actually going to ignore the problem on this page and just put up a number. In this case, it's going to be the number 0.9. And I'm just going to try some things and see if you notice a pattern. I'm going to multiply 0.9 times 10. Let's see what I get. 0.9 times 10 is 9. Okay. Now notice if you see a pattern here. I'm going to start 0.9 again and do times 100. So when I did times 10, I got 9. When I did times 100, I got 90. Let's keep going. What will happen if I do times 1,000? 900. So you notice that this 9 stays pretty consistent, but then as I multiply by larger multiples of 10, I get bigger and bigger numbers. And it seems that I'm really only adding zeros on the end here. So let's break down what's really happening. Every time you multiply by a multiple of 10, you're actually essentially moving the decimal place one space. You're essentially bumping up the entire value by a factor of 10, and 10 is the factor by which we count. So that bumps up each place value to the next possible place value. So when I take 0.36, I know this isn't exactly the problem, but when I take this and if I just multiplied it by 10, what I'm doing is I'm basically bumping 3 up one place value and 6 up one place value. So now this 3, instead of being in the tens place, is going to be in the ones place. And the 6, instead of being in the hundredths place, is going to be in the tens place. So the way that I most often think of this is I'm basically just moving the decimal backwards. So that now each number is in one place value higher than it was when I started. So 0.36 times 10 is 3.6. So now if I do 100, I'm doing this twice because I'm basically doing times 10 and times 10 again. And so now I'm going to bump it up another time. And now 3 goes from the ones place to the tens place, and 6 goes from the tens place to the ones place. And now I've got 36. Shortcut, easy way to think of it, so that's the why. But now let's do the how in a very simple, short way of thinking of it. The how is basically I just count the number of zeros that I'm multiplying by in the factor of 10, and that's the number of times I move the decimal point. So in the example of our problem, I'm going to take 0.36 times 100. I've got 2 zeros, and so I'm going to move this 2 times from 0.36 to 36. Now you're wondering, what happens to that decimal point at the end? It's still there. Remember, all whole numbers have a decimal point at the end, and you could add zeros after that, but they're just not necessary. They don't add anything to it. So we just normally leave that decimal point invisible. All right, let's do some more practice. So we figured out that this one's 36. How about this one? 0.56 times 10. Of course, on IXL, they love to trick you by just setting it up a little bit differently. It's the same thing as if I put 0.56 times 10 horizontal. Same idea. I'm going to count the number of zeros, 1 0, and then I'm going to move the decimal point that many times over. And I end up with 5.6. How about 100 times 0.5? 2 zeros, so I move it over twice. 1, 2. I'm going to end up with 50. Why don't I end up with 500? Well, pay close attention. If I have 0.5, let me write this here. If I have 0.5, the first time I move the decimal point is just moving it to the other side of the 5, and the second time is actually adding a value. And whenever you add the value, just put a 0 in there. And then if you end up with something like this, where the decimal's over here, well, now you really don't need the 0 at the beginning, because that 0 was just a placeholder for the whole numbers when it was in front of the decimal point. Now the decimal point's way over here, that 0 can just be dropped. Okay, got 50. 10 times 0.4, so this decimal point is going to move to the other side of the 4, and it just ends up being 4. How about this? Don't get scared. Just count the zeros, 1, 2, 3, and then move that number of spaces. 1, 2, 3. It's 451. Once again, don't get scared, because it's not a harder problem. The same process applies. 6 zeros, right? 1, 2, 3, 4, 5, 6. So I'm going to move this decimal point over 6 times. 1, 2, 3, 4, 5, 6. So that means I'm leaving space for 3 zeros on the end. So 9, 9, 5, and then 3 zeros on the end, because that would be moving it over. I started here 1, 2, 3, 4, 5, 6 times. And this might be easier to do on paper, especially at the beginning, so please write it out, do it by hand. I like to make this little egg crate motion just to show that I'm moving the decimal point over, and that helps me to visualize it. All right, and now it's your turn.